So here is our first scenario. I need to make this smaller. Okay, there we go. I hope you can see it now. So the context is these are two pie charts that show different sources of income for households. Okay. And we've got Western Cape on the left and we've got Northern Cape on the right. And this is for 2016. And so this is how many households have sources of income from these categories shown in the pie charts. Let's just understand this for a second. So for example, if we look at the left there, the Western Cape, it says sources of income. So there's a total number of households that they obviously surveyed, and they found, for example, in the Western Cape, there were 7. Remember, and these numbers are in thousands, hey? So whenever you read the number, you've got to add 1,000 to it. So for example, here we can see that there were 7 households that received their income from farms in the Western Cape. Okay. For example, as well, on the right-hand side here, there are 7,000 households in the Western Cape that didn't get an income from anything. All right. And then obviously the biggest one over here in the middle on the right-hand side, it says 1,404. So it looks like 1,000, but remember it was add on 1,000 to that, or add on 3 zeros. All right, which makes it 1.4 million. All right, so it's 1,404,000 or 1.4 million households in the Western Cape that receive their income from salaries. All right, so I hope that makes sense to you. So we need to understand these graphs before we actually look at the questions, because if you don't understand what the graph is telling you, then when you start doing the questions, it's your answers could be incorrect, or you might not understand exactly what the question is asking. All right, so this is a number of households receiving income from different forms of income in the Western Cape on the left and the Northern Cape on the right. And obviously these two are put next to each other to compare. In the real world, you want to compare the Western Cape with the Northern Cape. For example, salaries make up 1.4 million in the Western Cape. On the right-hand side, salaries only make up 205,000. All right, but that depends on how many households there are in the Northern Cape. We don't know percentages. Usually pie charts show percentages. These pie charts don't show percentages. Maybe they want us to calculate percentages. I don't know, but pie charts usually show percentages, all pieces of the pie making up 100%. But let's see, maybe the question wants us to answer a percentage question based on the information that we have here. All right, now I'm going to flick down to the question and up to the graph quite often. So don't get dizzy when I do this, but we've got the question underneath and then the data up above. So we're going to refer back to the data quite often. All right. So here's the first question. If the total number of households in the Western Cape was 2,768,000 during this year of 2016, calculate the number of households that depend on grants as a source of income. All right. So they give us the total here. They're saying all the income sources in the Western Cape, all the households, add up to 2,768,000. Therefore, calculate the number of households that depend on grants as a source of income. All right. Now, why did they give us that total? Well, if we go up here, we can see that grants over here on the left, bottom left here, has no value on it. Okay. And they say the total is 2,768, if I'm not mistaken. So 2,768, right? Just remember that this is in millions. So if I had to place this on the graph, I would cross out the 3 zeros for thousands. So all these numbers here on the graph need to come up to 2,768. I hope you guys understand that. So they tell us that, I'll do it again. They tell us that there's 2,768,000 households. Okay. This graph doesn't show full numbers. It shows numbers in thousands. So if I cross off a thousand or 3 zeros from this number, we'll get 2,768. All right. So 2,768 in thousands is 2.768 million. All right. So this number 2768 makes more sense now, because if I look at all these numbers on the graph, all of these, right, should add up to this total here, which it does now. All right. So 2768 makes sense when we look at all these numbers. All right. But grants are not included here. They're not shown on the graph. And the grants are actually quite a big part of this pie chart. So let's do this for a second. Let's roughly, and I mean really roughly, estimate the grants number. All right. Based on the size of the pieces, roughly estimate what you think the grants number will be. Put it into chat. What do you think the grants value will be based on what you're seeing here, the pieces of this pie, the total value that we have up here, 2768, and all the numbers that we see on this pie. Let's give an estimate of what you think the grants value will be based on just the piece or size of the grants pie, which is this piece here, right? That I'm outlining. That piece there, what do you think its value will be? All right, I've got someone saying 2050. Someone saying 714. Okay. Anyone else want to estimate what the grants will be? This highlighted red piece of the pie here. How big is it? If the whole thing is 2768, 2100, Howell says 2100. Okay. 714, 714. Are these people doing calculations that these 714s? Everyone's saying 714 because you did the calculation. Oh, that's not an estimate. So let's try and estimate as accurately as we can. We see salaries here on the right-hand side is 1404, and that salary piece of the pie looks almost half to me. Maybe not exactly half, but that salary piece looks like half. Then how big will the grants piece be? Some people are saying 714, 789. These people that are saying 714, you definitely must have done a calculation. 789 for Tando. Yeah, I would say in the 700s, because if a half is 1,400, this piece for the grants looks like it's almost a quarter, maybe a little bit more than a quarter. So 700s, I think, yeah, in the 700s somewhere is a good estimate. Okay. Now, what you guys would have done is you would have taken the 2768, if you want to do the calculation, and subtract all the other pieces, right? I think that's what you did. So I'm going to do it with you on the calculator. So 2768 minus all the other pieces, 117 plus 7 plus 180 plus 216 plus 1404 plus 7. Oh, interesting. Let me check that again. I don't know where the 714 and the 741 is coming from. Let me show you what I did. So what I'm doing is I'm taking the 2768, which is the total number of households for this whole pie, and I'm going to subtract all these numbers, the 117, the 7, the 180, 123, 216, 1404, and 7. I just want to make sure that I haven't made a mistake. So I'm going to do it again. So I'm going to say 2768 minus 117 and 7 and 180 and 123 and 216 and 1404 and 7. So I made a mistake. I think I left out the pension 123 there. All right. So these people are getting 714. They've done the calculation. Okay, good for you. All right. Do you see what we did there? We took the total number of households, 2768, and we subtracted all the pieces that we saw that had values, and that'll leave us with the grants value, which is 714. Remember, do not write 714 in the exam on your answer script. You got to write the proper value. All these values here are in thousands. Just remember that. Even though we're not using all the zeros in our calculation, you will have to add them back on in the end. So I'm not going to write out. In fact, let's just put the number there. So 2768 minus And then what I can do is work out what were all the other pieces together. I can take that away and actually work it out. 2054. So all of them come together to make up 2054. And when you subtract 2768 minus 2054, you get 714. Now, we are working here without the zeros. Just remember that we should have 3 zeros in there, hey? All right, we should have written 3 zeros in there. So in actual fact, it's 2,768,000 minus 2,054,000, which equals 714,000. So your answer should be 714,000 households. Hope you all understand that. Hope it makes sense. Can be a little bit confusing in reading and interpreting the graphs, but once you understand the graphs, it makes absolute sense. Just be careful that you add on the zeros, all right? The numbers are in thousands. Just remember that. All right, very good. Next question. Identify the third highest source of income for the Western Cape. Identify the third highest source of income for the Western Cape. You guys can look at the graph and identify it. The third highest source of income is what? Let me put down the grants. 714. Third highest source of income. Some people saying business, some people saying grants. What do you guys say? What do the rest of you say? Grants and business, business and grants, grants and business. Oh, very interesting. So the first highest source, the largest source of income, definitely comes from the salaries. That's the biggest piece of the pie, isn't it? The second highest source of income, the second biggest piece of the pie, must be the grants. So then the third highest income, the third biggest piece of the pie, must be the business income. All right. Okay, so salaries is first, then grants is second, and they wanted the third highest, which is business. Yes, there we go. All right, well done. So it's business. So looking at the graph, business is the third highest, the third biggest. So let's just write this over here quickly, and you can read the next question while I'm doing that. 2 marks in the bag there. All right, let's read the next one. Calculate the difference, the word difference, you know what that means, between the number of households in the Western Cape and the Northern Cape that depend on business. So the difference between the two provinces for business. Okay, the difference between the number of households for the two provinces for business. All right, there we go. There's all the information you need. What is the difference between the two provinces for business? Have a look at that. And put some answers up when you can. Or give us a thumbs up when you're done so we can move on. Well done. Well done to the people that are answering so far for putting in all the zeros. Good job. Well done. All right, Mohammed, good. But don't forget your zeros. Okay, that 188 could be correct, but don't forget the zeros. Yes, there we go. All right, good. You guys are remembering your zeros. Well done. Well done for remembering your zeros. Yes, good job. Awesome. Okay, so we look at business for the Western Cape. Is here on the left at 216, and business for the Northern Cape on the right is 28. Remember, each one has got to have 3 zeros. So let's put all the zeros in this time now. So it's 216,000 for the Western Cape minus 28,000 for the Northern Cape. Let me just check. 216 and 28. Yes, that's right. And this should give us, and I'll use all the zeros in my calculation as well, even though it won't make a difference, but let's do it anyway. As long as you add them on at the end. There we go, 188,000. Good job. Well done. Good. I actually enjoy this part of the Mathlet exam, interpretation of graphs that they give us. I actually really enjoy this section. All right, they give us the information and we just got to work with it. All right, well done. I don't know why this is 3 marks though. You see this is 3 marks for a very simple calculation. Makes me wonder. Calculate the difference between the number of households in the Western Cape that depend on business and source income. Well, we've done it. We've answered the question. All right, maybe they want us to state that this is the Western Cape and this is the Northern Cape. I don't know. I don't think you need to. But the two values are correct, read off the graph, and you subtract them. Maybe the 1 mark for two values being correct, maybe 1 mark for subtracting and 1 mark for the answer. That's probably where the 3 marks come in. All right, let's have a look at the next one. Question 4. Determine the percentage to 2 decimal places. Determine the percentage to 2 decimal places of remittances in the Northern Cape if there were 532,000 households. Okay, so we're looking at Northern Cape now on the right-hand side. They're saying if there are 532,000 households, determine the percentage for remittances. So if we go up to, let me just get this value, 532, and I'll write it up here. So 532, remember there are thousands there. I'll put it in red. They're imaginary zeros, okay? And we can see that remittance is over here on the left, remittances. They're saying determine remittances as a percentage if 532,000 is the total. All right. Now, please don't be fooled by the zeros again. Okay. Don't let the zeros catch you out. If I have to write this in full, it's 64,000. All right. So they want to know what is remittance as a percentage of the whole. Okay. This is what pie charts usually give us as a percentage. So we need to do a percentage calculation. We've got Chabo there already with answers. Good. Kudetsu, well done. Kudetsu, Margaret's iPhone, well done. We've got some values coming out now. We need to do a percentage calculation with these values, remittance and the total. It shouldn't be too difficult. All right, Tando. Okay, so it's a percentage calculation with those two values. All right, thank you. Well done, Fatima. Shouldn't take too long. Thank you for asking that. So I'll read the question again. Guys, just bear with me while I scroll down. Oh, please scroll down. Come on, come on, come on. Hold on, hold on, hold on. Is it going to work? It does not want to. All right, bear with me, ladies and gentlemen. I'm going to have to restart the engine. Okay, just bear with me. I'm going to restart this screen. I'll be back with you in a second. Bear with me, bear with me, bear with me. All right, come on, come on, come on. There we go, there we go, there we go. Takes a while for the engine to restart. Come on now. And there we go. All right, let's see the question 4 again. Where is it? Where is it? Where is it? It's up here. All right. There it is. Determine the percentage, 2 decimal places, of remittances in the Northern Cape if there were 532,000 households. So there's 532,000 in total in the Western Cape. Remittances over here in the middle on the left is 64,000. What is that 64,000 as a percentage? So we need to do a percentage calculation. All right, so I'll show you what it looks like. 64 and 532. So let's go down here. I'll write it down for you. So it's 64,000. I'm writing all the zeros now. And 532,000. So it's 64,000 of 532,000. And to get a percentage, I need to times by 100. So let's quickly do that. 64,000 divided by 532,000. And I want to times by 100. And that gives me 12,03007. Now, I'm not going to write all these decimals out tonight. Okay, we can see it's 12,03007. So I'm just going to round it off to 12,003. All right. Let's just do it nice and easy, straight into the answer, which is 12,03%. All right. Remember, they want 2 decimal places, eh? All right, Dine. Cool. Glad you saw that. Okay, so that wasn't too bad. All right, working with numbers on a pie chart. So important is to understand how pie charts work. All the pieces of the pie add up to 100. And also that this graph here, important to note for this one, is that all these values on the screen were in thousands. All right, it's so important to see that all the values you see here are in thousands. If you don't write the correct value, if you leave off the thousands, you could get it wrong. So don't do that. Please make sure, excuse me, that you change all the values to thousands. Yes, Tanda, I've got my 2 decimals. Yep, 2 decimal 12,03. All right, let's move on to one more pie chart question. Here we go. The pie chart below shows the total recycling and composting of material for 2015. So it says total recycling and composting by types of material for 2015. And here we have a value of 91,16 million tons. So if I had to write that out, it would be 91,160,000. Let me just move these 3 over. Hope you guys see that. That 91,16 million looks like that. 91,160,000. Okay. Sure, no problem. I'll go back to question 4. There it is. So we just need to work out a percentage, and we had to do it to 2 decimal places. And on my calculator, when we did it there, that's the value we got. So I just rounded off to 12,03. There's no numbers behind the 3, so we don't have to worry too much. Okay. All right, let's go back down to this question. So this is total recycling and composting by types of material. So these are all different types of material that get composted and recycled. Now, what's interesting to see is that there are 2 pie charts, but this is all for one value. So the value they give us here, 91,16 million, is represented in both of these pies. And you might ask yourself, how on earth they do that? Well, I'll show you. So on the bottom right-hand side here, you'll see a sector of the pie or a piece of the pie over here called other, right? Now, other means all kinds of different little things that they can't really draw into the main pie, all right? So they put a group of these small little things into one big piece of the pie called other. And then you see these lines here. There's a line going up there, and there's a line going over there to the right as well. So what that means is this yellow sector or piece of the pie can be represented by the pie on the right-hand side. So that yellow piece is made up of lots of little other things, which include rubber and leather, textiles, printer waste, cartridges, food, and wood. They just haven't been written into the main pie. They've been shown in another little separate pie, but this pie on the right-hand side belongs to the other yellow sector piece there. I hope you guys can see that and understand that. All right. So all of these here, all right, please understand that all of these here contribute to this 11,2% called other. All right, all those little pieces of the pie on the right belong to other in the main pie. Okay, so just remember that. So all these little percentages that we see here, 1,7, 2,9, 2,3, and 1,6, and look, there's one missing. They're probably going to ask us about that. All of those should add up to 11.2. They're just expanding that 11.2 to show you what's in the 11.2. All right, I hope you guys can see that. Okay, so let's have a look at the questions now. Glossary composting is the changing of words. All right, we know that. All right, question 1. Write down one possible data collection method that was used to gather the above data. Oh, now this goes back to the data cycle, right? You've got to pose a question or come up with a problem. Then you've got to find a way to collect data about that. That could be I'm not going to tell you how you collect data. What data collection method could have been used to get this data? This is not math now. This is information, right? Survey. Now, Gabo, that is the one that you always go to first, right? It's survey, isn't it? Excuse me, because that's how we often collect our data about problems that we have or questions that we pose. We collect answers via a survey. Well, let's have a look at the scenario. This is total recycling and composting by types of material for 2015. And we've got tonnage. It's a mass. So how did we get information about how many tons of each material was collected? Survey, survey, survey. What you guys are saying is that there were people that went to all the rubbish dumps and posed a question to the owner of the rubbish dump and asked him how much mass of each of these different types of material do you have in your rubbish dump? That's what you guys are saying. Look, survey is the go-to one, isn't it? It is the one that we think of first. I don't know if this was a survey though, guys. What type of survey do you mean? A questionnaire? Is that what you're saying when you say survey? A questionnaire, like people were asked. I think this might have been at a rubbish. They could have got this information from other municipality or the owners of the rubbish dumps themselves. Are you guys saying that a questionnaire was posed to the public to get this information? Is that what you're saying by saying survey? Or are you just copying what the person above you said in the text, in the chat? You could do that. You could take a questionnaire to people that are throwing away their rubbish. You knock on everyone's house doors and ask them, how much metal do you throw away? How much plastic do you throw away by weight? How many kilograms of metal do you throw away? You could get that information like this. I mean, it won't be completely wrong, but is it likely? Observation. I like that. Spelele, I like that. Observation. Yes, you could go to a rubbish dump, and in fact, you probably go to the rubbish dump, you go to the owner of the rubbish and ask them to show you their data collection because they must be weighing this. You could ask them once they've sorted and weighed it, can you show us the values for all these different types of materials? Or you could do an observation and estimate what the weight of all the materials are that are getting dumped when they dump it. You could do that, right? You must do an interview. Tando, that's good. Yeah, I think maybe they went to the rubbish dump and interviewed the owner, or they went to the municipality and interviewed the person in charge of all the municipal rubbish dumps and said, do you have information about all the different types of materials in the dump? If the municipality does keep that, then that's where they could get the data from. Or you could observe, you could sit there every day, but this is for 2015. You're going to sit there the whole year. So maybe you could sit there for a while and you could estimate, all right, this truck has brought in about, let's say it's about 8 tons and 60% of it is metal and 12% is glass. Research, Zio Bowman, that's very good. Gabo, I don't know because this is how often do you see this kind of question in a matric final paper? That's, I hardly ever see this kind of question, but it takes us back to even grade 11 stuff that we did. All right. When they talk about the different methods to collect data, or you could even Google the company. All right. Yeah, maybe you could. Yes, you could Google it. Research. I think research, a questionnaire directed to the rubbish dump. Okay. So use the knowledge that you have about this section of the work in math literacy, the data collection section, and try and recall the different methods that you remember were taught to you. And these ones that are coming up: observation, survey, questionnaires, research. They're all valid answers, but validate them. All right. What I mean by that is give a reason why you're saying that. Don't just say research. Say by doing research through visiting the rubbish dump and speaking to the owner, or visiting the municipality and speaking to the person in charge of recycling and composting material. Okay. So yes, a face-to-face. Yeah, I think speaking to the person or even emailing them, right? But don't just say email. emailing the owner of the dump to give raw data about what they measured at their dump. All right. So just elaborate a little bit on your answer. As long as your answer makes sense, as long as your answer makes sense and is relevant, you will get the marks. If you say something like by watching a TikTok video, that's not really relevant unless you have the municipal dump owner as one of the accounts that you're following on TikTok and he talks about this. But as long as your answer is relevant, okay, and makes sense, you will get the marks for it. So all of your answers sound pretty good. Using one word, please elaborate on the words that you guys have used, like questionnaire, observation. Elaborate on that. So for example, an example answer could be collecting data directly from municipality or waste managers. Now, if you say waste managers or municipality, if you don't write that, I don't think you're going to lose marks, but it's how you're doing it. So collecting data from municipality or waste manager, face to face. Yeah. All right. So as long as your answer makes sense, you will get 2 marks for that. All right. Finally, back to calculations, what we all feel comfortable with. Number 2, calculate the percentage allocated for yard trimmings. Calculate the percentage allocated for yard trimmings. All right, there we go. So there's all the information you need. There's the par, there are all the percentages. There's the total value for this pie chart. Calculate the percentage for yard trimming. So there's yard trimmings there. What is the percentage? Shouldn't take you guys long. You could estimate it. Looks like another quarter again, doesn't it? So it's got to be around 25%. There we go. There's Lee Strauss with an actual calculator. Looks like a calculated value. But if you estimate it, look at that. It's a quarter. That piece can't be very far from 25. Don't say 10 or 70. That definitely doesn't look like a 70%. All right, there's 23.4. All right, yes, good. So you guys are calculating it. So we know the whole pie makes up 100. All right, 100 minus all the other bits and pieces. So I'm going to add them up 3.4, making sure that I don't make a mistake like last time and forget one. Human error, 49.7 plus 11.2. I've got them all there. There we go. Yep, 23.4%. Well done. All right, so we know that all the pieces add up to 100. You subtract everything that you have, and it leaves you with what you don't have, and that will be 23.4%. Yes. All right, I'm not going to write that down because I want to get through the next questions, but you can see what you need to do. 100 minus all the other pieces gives you 23.4%. Please make sure that you write down the percent sign, hey? 23.4%. It's not on my calculator, but you will write it down. Okay. Yeah, see, it's easy to make a mistake, human error, especially when there's lots of numbers. All right, let's see what the next question is. Let's see what the next question is. Number 3, determine the percentage allocated for textiles. Determine the percentage allocated for textiles. Ooh, I'm not going to say anything. I'm not going to give you a warning. I'm not going to give you a hint. Determine the percentage allocated for textiles. Here we go. Textiles on the right there. Ah, Katlejo was already with an answer. These trials are the answer already. Guys. Yo. On fire. I'm trying to go slow. These other people online here are going super fast. All right, so we're trying to work out the percentage for textiles here. And please don't be embarrassed to ask to slow down. On the right hand side, we've got textiles here. We're trying to work out what is its percentage. Haven't even finished reading the question or saying it, and the answers are already popping up. Sure. All right, very good. The answers are all coming up there. Let's see how we do it. So first thing to remember is that in the second pie chart, all those pieces of that pie belong to this percentage here. So all those little pies, pieces of pie in there, the 2,9, the 1,7, the 1,6, and the 2,3, and textiles, they all belong to this section here called other, which is 11.2, right? So we have to make sure that all these little pieces add up to 11.2. So we can do the same calculation, just say there should all be 11.2. So if we take 11.2 and minus all the others, 1.7 plus 2.9 plus 2.3 plus 1.6, we should get our textiles to 11% on the money. Well done. I hope you see that. All right. So these should all 5 of them should add up to 11.2. So we take 11.2 minus all the other 4 to get the textiles, which is 2.7%. Ah, guys, I'm actually enjoying this. All right. Hope you guys are okay with that and saw how we got that 2.7. But let's see what other questions they have. Here we go. Question 4. Calculate in tons the total amount of plastic for 2015. Calculate in tons the total amount of plastic. There we go. There's the data. There it is, all in front of you. Calculate in tons the total amount of plastic. Can you see where plastic is? They want to know what is that piece of the pie in tons. Shouldn't take you long to try and get that one. And now all of you who are working on calculators exclusively and are not writing things down, that's fine for tonight. Please remember that what you write down is what you have to show in your answer. Sorry, what you have in your calculator, you must show in your answer script if you want to get all the method marks, eh? So please make sure that whatever you're doing on the calculator, you are writing down. For example, the previous calculation, what I have here in the bracket, you don't actually have to show every number. You could add them all up and just put a total there. But this calculation that I'm showing on my calculator here should be written down to show the marker that you know what you're doing. Your method is correct. All right, just please remember that. All right, anyone got an answer yet? How many tons is the plastic? Ah, Lee Strauss, very quick tonight. Good. Well, also, well done. Oh, even showing this 1,000 spacing in a number there. Good job. All right. Got answers coming out now. Don't look at what answers. You do your own. Okay, you don't worry about the answers coming up. You do your own and then compare. Okay, that's how we're learning here. All right. Good job. Good. Yes, well done. All right. Tana, just check your decimal point there. It might be 1,000 separator. I'm not sure. But let's try this one out. So the plastic is 3.5% of the total. The total is 91,16 million, which is why we need this whole value written out eventually. Okay, so I'm going to do the calculation on the side. So 3,4% can be written as a percent like this. So we need 3,4 of 91160. I need to zoom out a bit. 0, 0, 0. 91160,000. Yes, that's right. So let's do it on the calculator now. So 3.4 over 100 times by 91160,000. What? 3,099,440. 3,099,440 tons. All right. Yes. Well done. There it is on the calculator, the calculation, and there it is in my answer booklet, in my official exam answer booklet. That's what it should look like. Okay. Well done. Good job. All right. Let's see. Any questions about that, or let's move on to the next one. Question number, I know I skipped 5 because 5 wasn't really relevant. Wasn't very easy. I mean, it wasn't really difficult. It was very, very easy. So I skipped it because you guys are smarter than that. Question 6. State another type of graph that could be used to represent the data above. State what type of other graph could we use to represent this data? Come on, guys. What kind of other graphs could we use to represent this data? Bar graphs would have been the one I would have gone to first. Good. Yes, bar graph. Bar graph would have been the one I went to first as well. Bar graph, bar graph, bar graph. Yes, you can use a bar graph for this. Yes, well done. Histogram. Janu, now I'm so glad we've got the two together, bar graph and histogram. Line graph, I'll talk about line graph now. So bar graphs, all right, obviously we know are little bars and they are separated by spaces, okay? So I'm drawing a little bar graph here. There are 3 bars. Let's put in another one. Let's put in a 4th bar, and they're all separated by spaces in between. Histograms, oopsie, the bars touch each other. So it looks something like this. Yo, my drawing is very bad. The bars will all touch each other. So it could be the same size bars, but they will all be touching each other. Now, when do we use, who knows when we use which one? When do we use a histogram and when do we use a bar graph? Can someone tell me? When do we use a histogram and when do we use a bar graph? Why can't we just use a bar graph here? Why can't we use a histogram here? Does anyone know when we use a bar graph versus a histogram here? Anybody? Somebody? Anybody?
Just crickets. Crickets all around.
Hey. Wandile, yes. Please, guys, you can raise your hand. You can come online and talk to us. It's easier than typing out a whole essay. It's so much easier than typing, especially if you're on a phone. Yeah, there's Jenny with a cricket symbol. Anybody?
Somebody. There we go. Nakala, just look on your screen. There should be a message that is going to ask you to unmute. There we go.
Good afternoon, sir.
Good afternoon. How are you?
I'm good, sir.
Good. I'm sorry that we're going fast. We are going quite fast tonight. I'm very sorry about that. But thank you for slowing me down a little bit. It's also not just me. It's these guys online. They quick with their answers, eh?
Yes, sir. I understand.
All right. When do we use a bar graph and when do we use a histogram?
So well, we use a excuse me, we use a bar graph to okay. Can I just explain what does
Of
a
course.
bar graph do?
Of course.
Okay, so a bar graph explains oh.
You can use it to explain this data, but why can't we just use a histogram? Can we not just use a histogram for this?
So I think because a histogram doesn't work with percentages.
That's close. That's close. A histogram is for special numbers and not you could actually use it for percentages, but we don't, not in this scenario here, not these type of percentages here.
Oh, and another thing, in a
yeah.
histogram, you can write a lot of information in one poll.
Yeah, you're right. You're right with that. It's very simple in how it describes the data, whereas bar graphs can actually show a lot more. But you can have double bar graphs, compound bar graphs. So bar graphs can be used to explain a lot more. Histograms are a lot more simple. Yeah, you're right. You're right with that. Well done. Thanks for that. Yes, anyone else? All right, so Karabo has also mentioned something here. Grubber says, we use it to represent the data that's sorted into categories. Okay, so now you're going to talk about the different types of data. There's two types of data that we have. Let me rub out this previous question. I'm going to write the one type, and then you will obviously tell me what the other one is. So you get discrete and what? Yes, Sisabonga. So now the question is which one? Which one? We get two types of data, discrete or continuous. And a bar graph, yes, Peter, well done. Yes, so it's continuous, that's the other one. But which one do we use the bar graph for, and which one do we use the histogram for? That's the question. So tell me which graph is for discrete data and which graph is for continuous data? Yes, guys, it is continuous, but now which one goes where? Bar graph uses which one? And a histogram uses which one? Peter. Check your screen there, Peter.
I think bar graph we use it for the discrete data, and
Yes.
histogram we can also use it for the continuous data.
That absolutely well done. Perfect. So bar graphs you use for discrete data, and histograms is for continuous. Who can tell me? Peter, are you still there? In fact, my spelling is shocking. Got like 4 vowels in a row there. Absolutely shocking. Guys, my math is not bad, but my spelling, yes, is not make sure. All right. Who can give me an example of continuous data? Who can give me yes, Gabo. So let's do that. Let's explain the difference by giving an example. So who can give me an example of continuous data? When do you determine if data is continuous data? Lokola, just check your screen there again.
Yes, sir.
Yes. Can you give me an example?
So like a continuous data is data that can take any value.
Yes, you're right. So discrete is often only integers.
Yes, sir.
And continuous is decimal numbers.
Yes, sir.
Excellent. All right. Thank you very much. So integers, for example, discrete data is like, for example, counting cars. We've got 1 car, then 2 cars, then 3, then 4, then 5. You don't say, oh, there's 1,2 cars. Oh, there's 1,7. There's 2,39 cars. When you count objects, it's discrete data, it's integers, okay? Continuous data is usually data with decimals, and think about it like this. It's data usually often measured when you're measuring things. All right, for example, the heights of boys in your classroom, the distances that cars travel in kilometers, you can have decimal kilometers, okay? The height of boys, 1,23 meters, 1,63 meters. So if you can measure it and you have decimals, then you often use continuous data, okay? So that's the difference. Yes, discrete is whole numbers. Yes, hold on. Height, weight, and temperature. Very good. So those are all things that you can measure and you get decimals with them. But discrete is often categories like 7 blue marbles, 3 green ones, 4 yellow ones. Those numbers are discrete values. So that's linked to a bar graph. But continuous data is measured, and then you need a histogram. So coming back to your question, I think it was Bianca, for histograms, you will start at a value. For example, on my histogram at the bottom here, I'm going to say I'm going to start at 0. The next line will be 1, and then 2, and then 3, and then 4. But the bar covers all the values in between 0 and 1. So 0, 0.5, 0, 0.7, 0, 0.6. So if there were values here like 0.7 tons, 0.8 tons, and such like that, those will all fit into one of these bars. Okay, so it's from 0 all the way to 4 and all the numbers in between, not just those integers, but also all the numbers in between. It's like a ruler. A ruler has markings 1, 2, 3, 4, but it's also the little values in between there, 0, 2, 1, 7, 2, 3. It's also the decimals as well. Okay, so if your data is measured and in decimals, you often use a histogram to express it. If your values are counted and are in integers, then you could use discrete here. So let's, discrete can be counted, yes, yes. Kerutse, that's exactly right. All right, well done. Now, coming back to this question, let's all decide now. Question 6. State another type of graph that can be used to represent this data. State another type of graph that can be used. Can we use a bar graph or do we use a histogram here? What do you all think now? Bar graph or histogram? Yeah, I agree with you. I think we should still use a bar graph. All right. I think we should still use a bar graph here. There's also no intervals. You know, it's not like we classifying the numbers into intervals here like a histogram does. These are categories. So we can see metals, plastic, yard trimmings, other, paper, glass. Those words are discrete data words. Yeah, I would say bar graph as well. I would say bar graph as well. I would agree with you there. Okay, yes, I would agree with you. Definitely a bar graph as well. All right, let's have a look and see if there's one more question over here. There is one more question. Oh, look at that. Check. Look what they slipped into this question. You see, they're going to inject it into all the topics. Pretty much any single topic is fair game for a probability question. So let's have a look. Determine as a decimal the probability of randomly selecting a material in the other category that is not textiles. Determine as a decimal the probability of randomly selecting a material in the other category that is not textiles. All right. What's the probability of selecting a material in this category here, the other category, which is not textile? So we're only looking in that pie there. This is the other category pie chart, right? And one of them is textiles. They want to know what's the probability of not getting textiles. Not getting textiles. What's the chance if you pick one of these other materials in the other category, what's the chance that you'll pick not getting textiles? Now, let me just go down to the question again. It says, determine as a decimal the probability of randomly selecting a material. So we're picking materials here, not weights. We're picking a material that is not textile. Very interesting question. Anyone? It's crickets again. All right, I'll tell you what, we're going to save this question for Thursday. We'll start Thursday's 8.5. Yeah, 0.8 as a decimal. We'll start Thursday's lesson with this question. Just think about it. You can answer the poll in the meantime, and then take a screenshot of this. And I'll go down to the question, and we'll start Thursday's lesson with this question. It's actually a very interesting one because there's a lot of possibilities based on how you interpret the question here. So let's just take a screenshot of that circle there, and then I'm going to move down to the question. And we'll start Thursday's lesson with this one. Very interesting question. Yeah, Peter, the fact that you're saying I think, we need to dig deeper. This is a 4-mark question as well. It's the last one, which is usually, Spaghetti's also got something different. Okay, so there's the diagram. And here's the question 7. Determine as a decimal the probability of randomly selecting a material in the other category that is not textiles. And they've made the word not in capitals. They're trying to emphasize that. Very interesting. All right, we will start Thursday's lesson with this one and have a look at it again.